This video is over section 7.4, Zeros of Polynomials. So before we start, let's talk about the rational zero theorem. It says, if f of x equals a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus a sub n minus 2 to the x n minus 2, plus dot dot dot, plus a sub 1 x equals a sub 0 has integer coefficients, and a sub n is not equal to 0, and if p over q, written in lowest terms, is a rational zero of f, then p is a factor of the constant term a sub 0, q is a factor of the leading coefficient a sub n. That's a lot of words. First, let's unpack integer coefficients. So what that means is every number in front of x is written as an integer, which just means positive or negative whole numbers. Okay, the next thing we need to unpack, p is a factor of the constant term a sub 0, which is the last term in a polynomial, and then q is a factor of the leading coefficient a sub n. So when written in order from highest to lowest degree, the leading coefficient is that integer in the very front. All right, so furthermore, the rational zero theorem does not guarantee the existence of rational zeros. That's very important. So what we're doing does not guarantee we're going to find a zero. Okay, rather it indicates that if a rational zero exists for a polynomial, then it must be of the form p over q. And again, p is all possible factors of a sub 0, or that last term. And then q is all possible factors of the leading coefficient, or a sub n. I'll use my colors again just so you can see where we're getting them. So green is that last term, pink is the leading coefficient. All right, so for this first problem, it says list all possible rational zeros for the following. F of x equals negative 4x to the fourth plus 5x cubed minus 7x squared plus 8. And so what we need to do is, for our possible zeros, we need to list out p over q, and our p is our constant, or our last number here, so 8. So we need to think of everything that can divide by 8. And just know here at the beginning we're going to do a big plus or minus because this includes all positives and negatives for this. So factors of 8 would be 8 times 1 and 4 times 2. And then we do the same thing for q, where q, we list all factors of our leading coefficient negative 4. So again, we have that plus or minus in front. So factors of 4 would be 4 times 1 or 2, which is 2 times 2. Okay, so when we're listing all possible zeros, we want to consider all of these rational numbers. And so let's write them as a set down here. It's a horrible set bracket. There we go. Okay, so we're going to go really slow, and then you'll see the pattern pretty quick. So first I'm going to consider 8 over 4. 8 over 4 is 2, and then don't forget the plus or minus. So we're going to have plus or minus 2. Then we're going to consider 8 over 1. So 8 divided by 1 would be plus or minus 8. Then we're going to consider 8 over 2. 8 divided by 2 would be 4. So plus or minus 4. Okay, we considered everything where 8 is in the denominator, so I'm just going to mark this off to show that we've considered it. Next, we're going to move on to 1. So we have 1 divided by 4, which would be plus or minus 1/4. We have 1 divided by 1, which would be plus or minus 1. And then we have 1 divided by 2, which would give us plus or minus 1/2. So I'm going to erase this just to keep my work neat. And we considered everything with 1 divided by 4, 1, and 2. All right, next we're going to go to 4. So we're going to consider 4 divided by 4, which is 1, which, look, we already did that, so we don't need to rewrite it. Then we're going to have 4 divided by 1, which is 4. Again, we already have it, so we don't need to rewrite it. And then we're going to do 4 divided by 2, which is 2. Again, we have it, we don't need to rewrite it. So we did everything with a 4 in the numerator. Last, we're going to consider 2. So we have 2 over 4, which is 1/2. We have it. 2 divided by 1, which is 2. We have it. And then 2 divided by 2, which is 1. We have it. So that one is already considered. We just needed to make sure. Okay, so all possible zeros for the polynomial f of x would be positive or negative 2, positive or negative 8, positive or negative 4, positive or negative 1/4, positive or negative 1, and positive or negative 2. Again, these are possible zeros, possible rational zeros, sorry. But they would not be they would not be guaranteed. Okay, so it's not guaranteed that one of these is a 0, it's just possible. All right, let's do the same thing for g of x equals 5x cubed plus 6x squared minus 3x plus 15. So let's list out our possible zeros. And again, we're just thinking about rational ones. So we're going to be considering p over q, where p is factors of our constant term, which is 15. So we're going to put a big plus or minus in front. Factors of 15 would be 15, 1, 5, and 3. Some people like to put those in order. It doesn't really matter. You're going to get the same set at the end. And then last, we're going to consider factors of q in the denominator, and that q for us would be 5. So factors of 5 would be, we already wrote the plus or minus, so we're just going to have 5 and 1. All right, so let's list all of our possible factors, or zeros for us. So we're going to consider 15 over 5, which is plus or minus 3. And then we're going to consider 15 over 1, which is plus or minus 15. Okay, so we're going to mark off 15 just so we kind of keep track of where we're at. And then next we're going to consider 1 over 5 and 1 over 1. So we can add plus or minus 1/5, and we can add plus or minus 1. And mark that off. Next, 5, we have 5 over 5 and 5 over 1, which would be plus or minus 1 and then plus or minus 5. Notice we already have 1, so I'm not going to rewrite it. And then lastly, mark off that 5. We have 3 over 5, so 3/5 we do not have, so we need to add that one. And then 3 over 1, we do have that, so we don't need to add it again. So let's erase that. Mark off our 3. We checked everything. We have all possible factors. So zeros. All possible zeros for g of x would be positive or negative 3, positive or negative 15, positive or negative 1/5, positive or negative 1, positive or negative 5, and positive or negative 3/5. I'm going to highlight that rational in yellow so it stands out. These are all possible rational zeros. Okay, for these next two, it says find the zeros for the following. For this first one, we have x cubed minus x squared minus 4x minus 2. So first, we want to find the possible zeros like we did above by listing out all the factors of p over q. So just to keep organized, p is going to be -2 and q is a +1. When there's nothing in the front, that means there's an invisible 1 there. So for us, we're going to have a positive or -2, 1 for p, and then factors of 1 would just be 1. So I'm going to go ahead and list all these out. So 2 over 1 would be +2, and I'm going to list them all out. 2, -2, and then 1 divided by 1 would be +1 and -1. Okay, so we don't know which of these will work, but if you remember from the synthetic division video, the factor theorem says that if f of c is equal to 0, then x minus c is a factor, and that's going to be useful to us here. So what we're going to do is we're going to try our possible zeros using synthetic division, and we want to get a 0 in the end. Okay, so I'm going to make my little synthetic division table, and across the top I'm going to have 1, -1, -4, and -2, and I want a 0 here, so I'm going to write that so I remember. I want a 0 as my remainder. Okay, and then we're just going to try numbers from our possible zeros. So let's start with +2. So I'm going to bring down the 1, multiply and add, multiply and add, multiply and add. Okay, I did not get a 0 here, so that means that 2 is not a 0 for f of x. So I marked it off in my possible list, and then I'm going to erase everything from my table and try something else. So next, let's try -2. So I still want a 0 in the end. I'm going to bring down that first term, multiply and add, multiply and add, multiply and add. I did not get a 0 in the end, so I'm going to mark off -2, erase -2, erase everything, and we're going to try a different 0 and see if we can get something to work. So let's try +1. I'm going to bring down the 1, multiply and add, multiply and add, multiply and add. Okay, so I didn't get that again, so I'm going to mark off 1, erase everything, and then we'll try -1 because it's our last option. If it does not work, then this one would not be factorable. There's no zeros, but I think that it does work. So I'm going to plug in a -1 this time, bring down the leading coefficient. We're going to multiply and add, multiply and add, multiply and add. Okay, so we did get a 0 here. So what that means from that theorem that we pulled from last notes, x plus 1 times x squared minus 2x minus 2 is a factored form of f of x. And remember this relationship x minus c, oops, that's hard to see. X minus c is why we have a +1 here instead of a -1. Okay, so what that means is, well, the problem asks for the 0. So from here, we have our 0 of x equals -1. And if we could factor this, we would get 2 more zeros, but this one does not factor. So to get our other zeros, we're going to need to use the quadratic formula. So I'm going to do that really small, and I'm going to rush because this is a review. But really quick, this would be a, b, and c. And we're going to plug in -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to solve that. So when I plug that in, I'm going to write really small. That's going to be 2 plus or minus, I believe this is going to be square root of 12. Let me double check in my calculator. So we're doing -2 squared minus 4 times 1 times -2. And yep, I got 12. So all over 2a would be 2. When I reduce this further, I'm going to get 2 plus or minus 2 root 3 all over 2. And so I'm going to have x, I'll just write it new. I'm going to have x equals 1 plus or minus the square root of 3. So this polynomial had 3 solutions, because remember this plus or minus means there's 2 here. One of them was rational, and then the other 2 are irrational because they had square root 3 in them. Awesome. All right, same thing for g of x. We have 2x to the 4th plus 3x cubed minus 15x squared minus 32x minus 12. So let's list out our possible zeros. So we're going to take factors of p over factors of q, and they're going to be positive and negative. Remember here that p is -12 and q is 2. Okay, so for -12, our possible, or our factors for 12 would be 12 times 1, 6 times 2, and 3 times 4. So this one has a lot. And then for q, we have 2, so that would be 2 and 1. So we're going to have a huge set here. I'm going to write them all out because we kind of need to checkbox them like we did on the previous problem. And so when I do that, we're going to have, let's see, 12 over 2. I'm going to go fast because I feel like we're probably understanding this by now. 12 over 2 would be 6 and -6. 12 over 1 would be 12 and -12. 1 over 2 would be 1/2 and -1/2. 1 over 1 would be 1 and -1. 6 over 2 would be 3 and -3. 6 over 1 would be 6 and negative 6, which we already have. 2 over 2 would be 1 and negative 1. 2 over 1 would be 2 and negative 2. 3 over 2 we need to add. And then 3 over 1 we already have. 4 over 2 we already have. And then 4 over 1 we need to add. 4, negative 4. Okay, that's a lot. I actually do know the answer, and just for time's sake, I'm going to go ahead and work it as if I knew. So if I tried a bunch of different things, I often like to start with 1 just because it's a little bit easier to plug in. I'm going to tell you that 1 does not work. The next thing I would try would be 2's, and just to save us time, I'm going to go ahead with negative 2 because I know that it works. So I'm going to make my synthetic division table. When I plug in 2, the top row is going to be 2, 3, negative 15, negative 32, and negative 12. And again, I want my remainder to be 0 because I know the answer. I know this one works. If you didn't, you would try from this huge list, okay? So what I'm going to do is I'm going to drop the first one, multiply, and then add. I'm going to be very careful, multiply, and then add, multiply. I just want to be very careful. I'm going to double check. I think it's 6. I just don't want to mess up. Yep, negative 6, multiply, and then add. So I did get 0. So that means that negative 2 is a 0 for this polynomial. And now you could start over on this table, but you can also just extend your table going from these numbers now. So it's kind of like ignoring the top and then using these again. So I'm just going to do that. We're going to do it a second time and trying to get another 0 here. So we know negative 2 works, so I'm going to highlight that. We know negative 2 works, and that's why we can continue our table, and it worked because we got a 0 here. Now, I do want to show you that negative 2 for this one actually works twice. And so that's something you have to consider when you're doing this. So because negative 2 works twice, I'm going to show it again. So to bring down the 2, multiply and add, multiply and add, multiply and add. Sorry, that got a little crooked. Okay, so negative 2 worked twice. So that's great. And then because I know the answer, I'm just going to go quickly so we don't waste a ton of time trying different things. But if I was you, I would probably try negative 2 for a third time. I'd see that it didn't work, but then I would move on to 3's, and I'm going to tell you that positive 3 does work for this one. So I'm cheating because I know that it works. I'm going to bring down my 2, multiply and add, multiply and add. So 3 works, so I'm going to put it here. So now what we can do is we cannot really go in much further because 2 and 1 will give us, I'll show you, but once you have 2 numbers here, you really can't go much further. So we're going to write this in factored form. So this would give me x plus 2 times x plus 2, and that's from these 2 numbers working. The factor theorem says x minus c, so that turns into plus 2 for us. And then x minus 3 from 3 working. And then down here, hopefully you remember, it's not opposite, it's just what's left. And we started our problem with x to the 4th, and we took out 1, 2, 3 x's, so we'd be left with 1x. So what that means is 2 and 1 turns into 2x plus 1 because we need 4 x's total, and we have that 1, 2, 3, and then we needed a 4th x, and there's a 2 in front of it. Okay, great. So that's factored form, but the problem did ask us for the zeros. And so from the zero product property, we did that a while back, but this would be x equals negative 2. And that's multiplicity 2 because we're seeing it twice. And then x equals 3. And then the last one would be x equals negative 1/2. So this one has 3 solutions. But one of them has multiplicity 2. Okay, great. So this next one says find the zeros for the following. So possible zeros. Again, we're taking factors of p over factors of q, and we're remembering that p is negative 20, and q, there's nothing there, so q is 1. So factors of 20, big plus or minus, 20 times 1, 10 times 2, 5 times 4. All over factors of 1 would just be 1. So this one actually ends up being pretty nice. I'm not going to write it out this time, and then I'm also going to tell you this one's kind of hard. I don't think I would give this to you on an assignment, but none of these work. So even if you're going to check them all, none work, and so you would have to use other methods here. I don't think I'm going to give you one this hard, but hopefully you would notice that you can factor this one into x squared times x squared. We're trying to multiply to get negative 20 and add to get negative 1. So this would be 5 times 4, negative 5 times positive 4, and then we could use zero product property. I did want to show this one just so you could see a full picture, but this would be one where you tried everything and none would work, so there is no rational solution. So you'll see we're going to get irrational solutions, but this one has no rational solutions. Okay, sorry, back to this. So zero product property, x squared minus 5 equals 0, and we have x squared plus 4 equals 0. When we solve for x, we're going to have x squared equals 5. And then for this one, we're going to have x equals plus or minus the square root of 5. So that's irrational because the square root of 5 is irrational. And then here, I'm going to subtract 4, and I've got x squared equals negative 4. And then I square root, and hopefully you remember plus or minus the square root of negative 4 would turn into plus or minus 2 from the square root of 4, and then I, so this one is imaginary. So there's 4 solutions here, just none of them are rational. All right, last one, r of x, we have x to the 5th plus 6x cubed minus 2x squared minus 27x minus 18 for our possible zeros. We're going to be considering p over q, and just as a reminder, they're positive or negative. P is this negative 18. Q is the leading coefficient for this one is just 1, so this one should be pretty easy, no fraction. So for 18, we're considering 18 times 1, 9 times 2, and 6 times 3. All over factors of 1 would just be 1. So for our big list, we're going to have negative 18, 18, negative 1, 1, negative 2, 2, negative 3, 3. I'm going out of order, sorry. Negative 9, 9, negative 6, 6. Sorry about that. I think I got them all. Okay, again, I know the answers, and so for time's sake, I'm going to go ahead for us and tell you that negative 1 does work. So if I plug negative 1 into my synthetic division, I'm going to have 1. I need a placeholder for 4, because look here, there's 0x to the 4ths. And then I'm going to have 6, negative 2, negative 27, and negative 18. I cheated and told you that this one will give us a 0, and then let's just make sure. So bring down the 1, and I get negative 1 when I multiply and add, multiply and add, multiply and add, multiply and add, multiply and add. Okay, I'm going to highlight that 1 so I don't forget about it, but that one does work. And then I'm actually going to tell you that negative 1 works twice. That doesn't always happen, but for this one and the one we did before, that one did work too. We're going to bring down the first term, multiply and add, multiply and add, multiply and add, multiply and add. We got a 0 again, meaning that it worked. Okay, if I were you, I'd probably try it again, but I'll tell you just to save you time, that does not work again, but 2 does work. If you're confused where I'm getting these numbers, I know the answer. That's why I'm choosing these numbers, just to save myself time on the video. But if you're at home by yourself, you are trying these numbers until you get things to work. Okay, so here we're going to drop the 1, multiply and add, multiply and add, multiply and add. There we go. Here it's not obvious, but this one is done as well. There's nothing left in our list that will work for these 3. And so we are going to go ahead and wrap this up and write it in factored form. So we have 2 minus x, negative 1s. So as factored, that would be x plus 1, x plus 1. And then we have a 2, so x minus 2. And then our last row, there's a lot going on here, but we started with x to the 5th, and then we took out 1, 2, 3 x's, so we're left with x squared. So this one is going to be x squared. We have 0 for our x term, and then plus 9. So let me back that up so it's clean. So for our bottom row, I'll keep it pink, I guess. Bottom row, this turns into x squared plus 0x plus 9. That 0x is kind of weird, so I'll write it better here. And notice here, we can just write x plus 1 squared because it happens twice. And then we've got x minus 2, and then we're just left with x squared plus 9. So if we need all the zeros from here, this one's pretty self-explanatory. This one is going to be x equals -1, which makes sense because that's what we were using for synthetic division. For this one, same thing. We've got x equals 2. Oh, don't forget here, this is multiplicity too, because it happens twice. And then this one is a little different. We need to use the zero product property and actually work this one out. So here we're left with x squared equals -9. X equals plus or minus the square root of -9. And when I do that, I'm going to get x equals plus or minus 3i. So this one has 2 imaginary solutions along with 1, 2, 3 rational solutions. And I got 3 because one of them has multiplicity too.